Today I'm gonna show you using the last parts what we have seen in our videos. I discuss about different trigonometric identities, especially double angle formulas. So using those double angle formulas, how could we find other trigonometric identities? So I will start from the first addition formula, addition identity of trigonometry, sine identity. I have the identity sine a plus b is equal to sine a cos b plus cos a sine b. Using this trigonometric identity, I will show you what we call the double angle formula, sine identity. Remember, what's sine of 2x? Now, we apply the additive identity here to find sine 2x. So sine 2x can be written as sine of x plus x. Now apply the additive identity. So sine of x, sine a cos b, sine x cos x plus sine of x cosine of x. Sine x cos x plus sine x cos x. That is 2 times sine x cos x. This is the double angle formula for sine 2x. The other trigonometric identity what we have seen before in our series, the cosine of a plus b. We prove that cosine of a plus b means cos a cos b minus sine a sine b. This is what we have. Now we need to use what we know to find the other trigonometric identity, the double angle formula for cosine. That is, what is cos of x plus x? That's 2x. Now we need to use this trigonometric identity. So cos 2x, it can be written as cos x plus x. A plus b. A is x, b is x. So a is x, b is x. Substitute in this formula. For a, x, for b, x. This is cos x minus sine x. That is cos square x minus sine square x. We have cos 2x means cos square x minus sine square x. Remember what we have. The basic trigonometric identity sine square x plus cos square x is equal to 1. From that we can get 2 identity. That is sine square x is equal to 1 minus cos square x by subtracting both sides, cos square x, or by subtracting sine square x both sides, we can get cos square x is equal to 1 minus sine square x. Now by substitute these two results separately on the equation what we have here, cos square x minus sine square x. This can be written as, first let's use cos square x. What's cos square x? 1 minus sine square x. So 1 minus sine square x minus, we have here already sine square x. So when we simplify this one, it becomes 1 minus 2 times sine square x. So cos 2x is 1 minus sine square 2x. Now from this also, important trigonometric identity can be derived. Look, cos 2x, 1 minus 2 sine square x. By adding and subtracting both sides the same number, we rearrange, we manipulate this expression, and it can give us 2 times sine square x is equal to 1 minus cos 2x. 1 minus cos 2x. Then divide both sides by 2. That's helpful for calculus. Divide both sides by 2. That will give us sine square x equal to 1 minus cos 2x over 2. This is the other trigonometric identity. That's very important, especially in the case of calculus, in the case of derivation, in the case of integration, especially in the case of integration. Mostly use this trigonometric identity. We have a lot of trigonometric identity, but we can construct like this. To get this one, we substitute here cos square x by 1 minus sine square x. Instead of that, if we substitute sine square x by 1 minus cos square x, cos 2x is equal to, look, cos square x minus sine square x. Substitute sine square x, 1 minus cos square x. Okay, cos square x minus in bracket 1 minus cos square x. This is equal to the negative sign distribute over, that's multiplication distribute over addition. Cos square x minus 1 times 1 minus 1 minus minus plus cos square x. So cos square x plus cos square x, 2 times cos square x minus 1. Now from this we simplify it and it will give us 2 times cos square x. Add both sides and subtract both sides, these two values. Add and subtracting the same value in an equation. So 2 cos square x is equal to 1 plus cos x. Adding both sides, 1. This implies divide both sides by 2. So cos square x is equal to 1 plus cos 2x over 2. These two trigonometric identities are helpful to convert our equation to linear form. Look, 1 minus cos 2x over 2. They are linear. Thank you for watching. I will get you in the next video.